Hello, welcome back to Cracking the Cryptic, and this is a puzzle by our friend Blobs, who obviously created our latest worm, the eclectic Sudoku worm. 12 6x6 puzzles, all connected by digits. It's fantastic fun, and it's available on our app, on the CTC app. You can add Blobs' worm as paid content, and it is well worth it. Very, very reasonable pricing, to be honest. And of course, there are other puzzles on the worm. Other apps within the paid content, including Line Sudoku and Classic Sudoku 2, and they're great fun. I mean, I'm not blowing our own trumpet. It is definitely true. They're by some of the best constructors in the world. Now, Blobs is one of those. That's why he's a contributor. We've also, of course, got Patreon, where Blobs has contributed several of our Sudoku hunts in the past. The latest one was by, April's, was by Sandra and Nala. And it was great fun, Bug Friends. And of course, we've also got gridogram connections and crossword videos. We've got merchandise. You can check that out. Store link or in the description field. And of course, there's Minute Cryptic, Wordle in a Minute, 2 videos every day, streaming on Mondays, masterclass crosswords on Fridays, so much going on. But let's have a look at Lynx. It's got the double arrow rule, which I like. So normal Sudoku rules apply. 1 to 9 will go in every row and column and 3x3 box. Digits don't repeat along each marked diagonal. Those are the light blue lines, so that's a set of the digits 1 to 9. And the sum of the digits along a double arrow line is equal to the sum of the digits in the attached circles. So those 3 will add up to those 2, etc. So give it a try. It's called Lynx, possibly because a lynx has 2 sharp eyes and they look like the circles. I don't know. Let's get cracking. Does it look to you like these lines bend a bit because of that's one of these optical illusions, isn't it? You have those diagonal lines and then it looks like straight lines have a little bend in. Maybe it's just to me. Anyway, what shall we do to start? I wanted to start with these lines because we know the sum of this box. It's the secret. It's 45. That's always the sum of a box in Sudoku, or a row, or a column. It's the sum of the digits 1 to 9. So let's imagine this was as high as it could possibly be, a 9, and those added up to 12. These would add up to 33. And then that would force and that's the absolute minimum. If we reduced that 9, and it can't be 8 or 7, if we reduced it to 6, with 9 there, these would add up to I want to say 36 again. Oh, I didn't say 36 before, I said 33 before. These would add up to 36. Right, if that was a 6, these would add up to 36. These would have to average 9. Well, you could put 9 in each of them, but there'd be clashes that aren't allowed. So that is clearly impossible. And if you go lower than 6 in the central cell, you'll exacerbate that problem. And these will have to average more than 9. So we're going to go with a 9 in the middle. Now these do sum up to 33. And that means these cells, I'm just going to briefly colour them yellow, also add up to 33. And one pair of them, the maximum pair you could put in 2 of these are 9 and 8, that's 17. That would leave the other pair to add up to 16 and be 9 and 7. Well, that is what's going to happen, because you can't put anything less than 9, 7 or 9, 8 in them, or you couldn't make up the other one. So given that they don't add up to 34, they only add up to 33, these must be a 9, 7 and a 9, 8. They definitely include 9 in both. And that means these lines, one of them adds up to 16 and one of them adds up to 17. One of them must contain a 3 though. 3, 6, 7, oh no, 8. Okay, so I don't know. But that's very interesting. So we've got a 9 here. We've got a 9-8 and a 9-7 pair here. I mean, these are the long... I should really have been thinking about these from the start, shouldn't I? So the minimum pair of digits here, where there's already a 1 in the box, are 2, 3. So that's 5. I'm looking at the minimum here. 1, 2, 3, that's 11. And here, 1, 2, that's 14. So this pair adds up to at least 14. So the minimum digit is a 5. I don't think that works over... Oh, we've got a 3 on the line already. So maybe 1, 3, 1, 2, 3, 1, 2 is 13 minimum. Now that would allow a 4 to go in one of these cells. But it doesn't allow them to be very low. Now this digit has to be higher than that, because this is that plus that. So the minimum these can be is... Well, no, the minimum one of them can be is 3, which means the minimum either of these knuckles could be is 4. That's not so helpful. Oh, where does 1 go in this box, though? It doesn't go in those cells, so it's in one of those two. I mean, it's quite likely to end up in the circle. It's quite likely to end up 1 in both circles, actually, but I don't really have the information to make that a go yet. Can I use the diagonals yet? I don't know. I got a 9 on one of them, so 9 has to stay off the diagonals for the rest of their course. Now, I don't know how to use that information. This one can't be a 3. So if one of these circles has to contain a 3, it's that one. This one has a minimum digit of 4, and that means that's got a minimum digit of 5. I don't know, it's not very strong. Okay, let's look at the degrees of freedom here. So these could be a 9 and an 8 if they're in the right order, and add up to 17. We worked out their minimum sum on the line was 14. So there are 3 degrees of freedom there. So the 1, 2, 3 could include a digit as big as 6, but no more than that. The 1, 2 pair here could include a digit as big as 5, but no more than that. You can see now I'm marking these up just in case it helps me. The 2, 3 pair here has got 3 degrees of freedom, so we could go up to 6 again. It's not that helpful, and I'm quite surprised how few arrows there are in this puzzle, if I'm honest. Okay, let's say... okay, in one of these columns there is a 9-8 pair in the yellow cells, and the other 3 cells that have got the line on also add up to 17. That will be a total of 34. And the rest of the column adds up to 11, and that would have to be 1, 2, 3, 5. So where the 9-8 appears, the line contains 7, 6, 4. So one of these lines contains 7, 6, 4. I'm just going to write that as a sort of aide-memoire in red here. The other line must contain 3, 5, 8. Now I don't know which side is which. This could be the 3, 5, 8 line. And then 7 and 9 will be its circles. And the other ones in the column will be 1, 2, 4, 6. And in one of the columns, the other ones will be 1, 2, 3, 5. And that's just led me to write all the low digits in all of these cells in a very unconvincing way. Now these can't have a 1 on. Yeah, I don't know. I mean, I thought I was making some progress. Oh, these digits can't be 8 or 7. We're selecting from 3, 4, 5 or 6 there. So on the line that has 4, 6, 7, there'll be a 4 or a 6 here. On the line that has 3, 5, 8, there'll be a 3 or a 5. So one of those is odd and one is even. I don't think that's going to help us solve it. Although, Well, it's going to mean something for the diagonals. It's going to mean that 8 appears on one of these diagonals and 7 on another. You see, that is a little interesting. 8 on this diagonal, say. It can't go here, I think, because that would blow the number on this line sky high. 8 there, and 1, and 1, 2, 3 would be 15, 18, 19. That is just too high for a total that can't be more than 16. So, eight could be here on this diagonal, but otherwise it's on a line in the central box. 8 on the other diagonal, again, I don't think it can be on the lines. And if we were to have 8 in the corner, it couldn't be on the corner of the other diagonal. It would have to be, well, no, it would be in one of these two, wouldn't it? But if it was on this diagonal, then it would have to be off the line on the other diagonal, and it would be in one of those two. Is that doing something really clever? I cannot quite see it. Oh, Blobs has set us a real challenge here. Okay, here's something about... Right, I pencil mark these, having calculated them, without using 7, 8 or 9. So in these boxes, 7, 8, 9 are confined to these T's. Yes, 2 of them are in the yellow cells, but in each box there must be another one of them in the struts of the T's, in the tall bits. So in one box it's going to be a 7, and in the other box it's going to be an 8. Now, it is never going to appear in this circle, the inner circle, because the outer circle, no, because the knuckle would have to have a bigger digit, and 7 is in one strut and 8 is in the other strut, so it's never going to appear there. Could it miss both lines entirely and 7 and 8 be at the top and bottom? Maybe. That's annoying, because I was wondering if I could confine it to the 2 knuckles, the 7 and 8, and then 7 would have to be here and 8 would have to be there, but I don't think that's a guarantee at all. No, I need to be doing something cleverer with the diagonals, I think. Or do I? Maybe I just keep marking up 1, 2, 3, 4, 5, 6. It is quite interesting. So the rest of that row, obviously. Now on this line, what was the biggest digit we could have? We could add up to a maximum of 16. Let's imagine that was at its lowest, 1 and 3. This was 1, 2, 3. That's 10. This would at its highest be 6. So the biggest digit you could put on is a 5. Going the other way, let's imagine that was as low as it could be. 1, 2, 1, 2, 3. That's 9. Plus 3 is 12. That would have a maximum of 4. And if that was at its lowest, 1, 3, and this was 1, 2, that would be 7. We've got a 16. This could go up to 6. No, you're never going to get a digit higher than 6 on the line. So we are finding quite a lot of cells, including these. 7, 8 and 9 can't go in those. A lot of cells where 7, 8 and 9 can't go. I'm getting to the point where I'm going to colour them. So I'm going to take out these aide-memoirs. They're very interesting, but they're wrong. They're not the candidates for those cells. I'm now going to colour all cells that I've definitely found that have to be from 1, 2, 3, 4, 5, 6. There's a lot of them, spoiler alert. Right, all of those definitely are from 1, 2, 3, 4, 5, 6. And let's make yellow the other ones that we definitely know are from 7, 8, 9. So we've had 5 of them in many areas. In box 8, box 2, column 9, column 1. None of these can be 3. Have we reached 6 of them somewhere? Even in these columns, it's 1 of each. Yeah, I don't know. It's interesting, but it's not conclusive. If that was the 7, 9 pair, 8 in row 3 would have to be here. And then you'd get an 8 here. Don't know what to make of that. That's obviously blue as well. It's not enough, and the diagonals aren't providing any particular help. This digit can't appear anywhere on this segment of the line. If it was a 1, this would be 2, 3, 4 adding up to 9. These would be 2 and 3 minimum. In fact, 2 and 5 minimum, because we'd have to get up to 5 in this lot. So 9, 14, 16, and we'd still have 2 cells to go. That can't be a 1, because we couldn't keep this down to 17. I suspect this can't be a 1 for the same reason. Again, we'd have, let's say 2, 3, 4 there, but, well, no, let's start with 2, 4, 5 here, and a 2 here. That's 13, plus the 3 is 16. We're already going to be, as soon as we add 1 more digit, we're past the possible total. So that can't be a 1 either. So the 1 in the central row is in one of these cells. That's interesting. But again, maybe it doesn't actually butter any parsnips and get us to a conclusion. How is Blob seeing this for us? And why can't I see it the same way? Oh, let's work on the minimum again. 1, 2, 3 here. Seems... Or maybe the minimum of both combined. Is that... Do they offset each other? Oh, they do a bit, because they go through this quadruple that all have to be different. These 4 cells all see each other, either vertically, horizontally, or diagonally. So they all have to be different. Let's call them a 1, 2, 3, 4 pair. That's worth 10 to these 2 lines. Then let's assume that these could somehow both be 1, 2, 3 triples. We're up to 16, 22. We've got that 3, 25. Let's call this a minimum 2, 27, and this a minimum 1, 28, and this a minimum 1. 29 is the absolute minimum, and I think we'd really have to juggle like demons to keep it down to 29 in both lines. Now, how would we achieve 29 with these? 2 of them could be 9, and the others would only have to add up to 11. 8 and 3. Oh, that didn't prove anything. That is disappointing. That's very disappointing. But maybe I've been ridiculous in assuming that we could have so many 1s. I mean, I think I postulated a 1 here and a 1 here. That will give us a 1 here and maybe a 1 here. Oh, I don't know. I think as soon as you lose a bit of control, the numbers spiral and get much bigger, but I can't see quite how it works. Sorry, I don't know what the solution to the puzzle is. It's really interesting, but I haven't got it. I haven't even really done the break-in. I mean, this was something in these yellow cells, but it wasn't everything. Can I somehow rule out 8 here? That would put 8 here by Sudoku. We'd know that 8 would then be in one of these cells. Oh, 8 wouldn't then be allowed in the other yellow cells. It would have to be here and in one of those two. We've obviously got it there already. Now, it would have to go on this diagonal somewhere, so not there. Got it there. It would be in one of these two. Okay, that would fulfill all my 8s. So it is possible for it to go down here. If it doesn't go down here, it goes on this diagonal somewhere. Either there or here. So if it goes there, then what? And I don't really know. No, I'm sorry. I'm getting myself into a bit of a puzzle here. What digit is going to rescue me from this confusion? I still think it's not going to take much to get this rolling. But do I have it within me to achieve that? Right. What about these 4 corners? They could include 7, 8, and 9, but they can't include any repeat digits. No, they can't include 9. So these corners can only include an 8 and a 7 at best. And then they have to have 2 blue digits. Well, one of them has to be in column 1, and one of them has to be in column 9. So the corners do have to include a 7 and an 8. And the 8 corner must be over on the left side of the puzzle because it can't be on the right given this. And the 7 corner must be over on the right side of the puzzle. Well, that's quite interesting. That's something that I hadn't learned before. And that's because we can't have both of them be blue in either case because we'd have 7 blues in the column. That's too many. Now, I want to say 8 and 7 won't be on the same diagonal here, so they'll either be in the same row or column. Is that right, though? I'm not sure if I know whether that's right. What it does mean is I think since we can only have 1 high digit in each column, these 2 must be yellow, and that must be yellow as well. These are from 7, 8, 9. And of course, those 2 can't be 8. Well, that's quite interesting too. This one can't be 7 because 7's in a corner. This is 9. That one now can't be 9, and it can't be 8 because 8's in a corner. That digit is 7. This digit is 9 by elimination. That is bizarre. How has this happened? I don't even understand how that's happened, and I couldn't see it before. Now where's 8 in this row? Because of that, it's here. And this is the sum. This is now blue. We've got 3 blues here. Okay, I don't know what to do with that, but this is the sum of these 2. So that can't be less than 3. This can't be a 6. It can't be a 1 either. So it's not where 1 goes. So the 1 is placed here in the box. That's where it's got to be by a form of Sudoku magic. Right, now up here, these are at least 2 plus 4. The only way this is not yellow 7 is if it's the number 6. So this is 6 or 7. I can't colour it. One of these two is a 7. If that's 6, this is 2 and 4. Oh, this was a fast. This is blue because it sees 9, 8, and 7. This one, not quite so sure. I'm still grappling with, are these corner digits on one on each diagonal? I feel I ought to know the answer from the central box, but I haven't grasped that yet. Right, this is an 8. So 4s are not available for its circles, or you'd have to have 2 of them. These can't have an 8 on. They're a 7-9 pair. That means these are a 9-8 pair. Now we've got 8 there, 8 in one of those, 8 in one of these 2 cells by Sudoku. Oh, this can't be 9 anymore, which is always quite interesting. And one of these 2 is 9. Now I sort of want to pencil mark 8 in one of those 2, but I've got these corner marks going on, which I don't really want to mess with. This can't be 9 either. Seven is there and in one of these, so it's in one of these 2, and I don't want to mark that for the same sort of reason. This is blue because it sees 7, 8, 9. Now, I need to focus on this and prove why it's not 6, which I'm sure it's not. If that was 6, this couldn't be 6, and this would be a 3-5 pair. This digit would see 6, 3, 5, 2, 9, 1, 8. It couldn't be 7 because of its colour, so it would be 4. That's if this was 6. Right. That fails. That is how it fails. So let me check if I got this right. If this is 6, this is 3 or 5, which on this 8 arrow makes this 3 or 5. This digit now sees 6, 2, 9, 1, 8, and the 3, 5 pair, and it's not 7, so it's 4. Now this can't be 6 or 4. You've got 6 there. This is 5. That has to be 1, but it can't be. So this is 7. Which is what we expected, but it's nice to be able to prove it. And then we get a couple of blue cells. And now these ones at the top and bottom are from 3, 4, 5, 6, which is not really the way we wanted to narrow them down, because it doesn't narrow them down much. But 7 there is going with 6, 5 or 4 here. Well, it can't be 6. It's 5 or 4, and this one is 2 or 3. That is the most constrained one cell arrow. This one is not as good. So we've got a 2 or a 3 there, and a 4 or a 5 here. Oh, what were these? What was my aide-memoire saying? Where we had a 9, 7, there was an 8 on the arrow, along with 3, 5, I think. And the other one, yes, because the other one was 7, 6, 4. 9, 8 in circles, 7, 6, 4. So, which one can't go this side now because of that? Neither. I don't see what that's providing. Okay, if this digit was 5, you would have a 4. Oh, that's lovely. This can't be 5 because that would be 3 on its arrow. This would be 4 and that would be 3 on its arrow. And where would the 3 in column 5 be? There's nowhere for it. So this is not 5 and this is not 3. So that's narrowed it down a little bit further. Not quite far enough. Wow, again, I just feel like I'm missing a trick. Big time. Oh, well, we've had this sees 7, 9, 8, so it's not yellow. Yeah, let's find other digits. Are there any others? This one sees 7 in the column, 9, 8 in the row. There probably aren't that many, but that is quite a few of the ones on this diagonal now. But I still don't know if you could put both digits on one diagonal in the central box and get away with it. Maybe the point is you have to. Oh, I don't know. Okay, we've got a 9 there and a 9. Oh, well, sorry, we've got a 9 in one of those and 9 there. One of these two is a 9. Now, if it was here, the maximum these could add up to is 14 with a 6 and an 8. Now, would that cause a problem? 1, 2, 3, 6, 2, 3, 11, 1, 2, 14. Right. What would go wrong with that? Something would probably go wrong with that. If this was, so I'm trying to prove a 9 in this circle. If this was 8 and this was 6, we'd definitely have 1, 2, 2, 3, and 1, 2, 3. Well, there is a problem with that, and that's 3 2s in columns 8 and 9. So that is not what's happening, and this must be a 9. And I mean, that's very unsurprising, probably not going to dramatically help, but it does mean that 14 is not enough for this total on this line. And that might also mean, oh no, this isn't going to repeat 2 or 3, is it? So what was the minimum here? I was probably claiming 1, 2, 1, 2, 3. Yeah, that is 6 digits from 1, 2, and 3. We can't have a 7th in the same 2 columns from 1, 2, and 3. So one of the digits is going to have to go outside. So if we say 1, 2, 3, 1, 2, 3, that's 12. And one digit that is higher, we get up to at least 16. This is the point. That's what these arrows have to achieve. They have to achieve at least 16. So on this one, it's got to be a 9 and a 7, and we know the order. That is huge, and that is probably the more important break-in that I haven't been doing. At least I got there now. Now, is that the same here? This is the same, only more so here. Again, if you were to put 1, 2, 3 twice in these 6 cells, you would have 12, and you would have used up all the 1, 2, 3s for the columns. And that would be at least a 4. So again, it's at least 16, so this time it's 17. That's a yellow. Ah, I did not see that. I did not understand that concept, and it's vital. Right, we get a lot more blues now. Now, this is the only possible yellows in the box. That's a 9-7 pair. This is the only possible yellow. This is not how I was planning to solve the puzzle at all. Right. What else do they see? I don't know. That can't be 7 in the corner because we've got a 7 up here. So the 7 in the corner is down here. I'm glad I left those pencil marks in. 8 is ruling out 8 from there. 8 in the corner is up here. And we've got probably all our, well, in many boxes, we've got all our yellows and blues done. Those all go blue. That corner goes blue. That in the top row goes blue. That in the bottom row goes blue. So this is yellow and 8. And have I got another? Oh, I've got the diagonal. Look, this diagonal has had both its big digits. So those go blue and these go yellow and are a 7-8 pair. And if I can disambiguate those and get these circles, I'm in business, but I'm probably a long way from that. That's a yellow and is a 7. Right, but we're progress. Progress is underway. The trouble is, now I'm going to have to do the littler digits. Okay, this is the harder line because it's 16. So what I learn on this line is the absolute minimum is 1, 2, 3 twice each for 12 and then a 4. And that's how I'm going to achieve 16. So I'm never going to have a 6 or a 5 on the line. And now I've got a 1, 2, 3, 4 quad, and that is 5 or 6 instead. And this line, well, that can't be a 1, 2 pair. How does that play? I don't really, I've got to know, but I don't know. But we're adding up to 17 on this line, so we've got a degree more of freedom. So if that was 2, 3, and that was 1, 2, 3, and that was a 1, this could be a 5. I still don't think we can have a 6 on the line. That's a step too far. So I've got to use these digits somehow. That's a 1, 2, 4 triple. This digit is 5 or 6 at the end. I hadn't thought about that. Okay, what about, oh, I don't know. One of these was going to be odd and one was going to be even, but I don't know. They could be the 2 low digits. That would really help the lines. Oh, Blobs is so clever. Okay, what else have we got? What else have we got? So one of these lines is showing 7, 6, 4 as the 17 total, and the other is showing 8, 5, 3. So if this was doing 8, 5, 3 with 9 and 7 in the circles, we'd have that as a 2. And 4 and 6 in these spare cells. And on the other side, this would be, what was it, 7, 6, 4 with 9 and 8. And that wouldn't rule on what this was at all. Ow. Blue chip bobbins. Okay, we need a 1 on this diagonal. This is a vital deduction that has been sort of available the whole time virtually. 1 is now in one of those 2 cells. Wow, if it was there, I think we'd have a problem on this line. Or would we? No, we could still have 1, 2, 3 twice each amongst those cells. So we wouldn't necessarily have such a problem. By Sudoku, 1 has to be in one of these because of that 1. I'm sure. Okay, if we didn't use 1, 2, 3 twice each, if we tried to use 1, 2, 3, 1, 2, 4, that would add up to 13. You could use a 4 twice is what I'm saying. 1, 2, 3, 1, 2, 4, 4. That would work on the 17 side, but it wouldn't work on the 16 side over here, where we've got to have only 1, 4. We've got to have 1, 2, 3 used twice. So in this column, we're going to use 1, 2, 3, 4. In this column, we're going to use 1, 2, 3. So we're not going to use 4 in this column. That is a 1, 2, 3 triple. The other digits in the column are 4, 5, and 6. That's interesting. It's blindingly obvious, and I haven't seen it before, but I've seen it now. Now I want to know how to use it. Maybe this quadruple, that all have to be different because they all see each other. I don't know. 4 is not, okay. That means this can't be a 1, 2, or it can't be a pair from 1, 2, 3. We have to have a higher digit here. Right, that is good, because these have to be at least 1, 2, 3, 4, and one of these has to be more than 3. So that's it. That's how we're going to get to 17. We're going to have 1, 2, 3, 4 here, no 5, and 1, 2, 4 here. The absolute minimum where one digit is more than 3. That's what we're going to have. So this digit is not 2, 3, or 4. That's a 5, 6 pair. Now we do have 3 and 4 in those cells. This can't be 3. This can't be 4. Ooh, that's a 1, 2 pair, and this is definitely 3, and that's the first blue digit we've put in the grid. These can't have a 3 on. Doesn't quite prove there has to be well, it does prove there has to be a 3 in one of those cells in this box, so that can't be 3. That's not really everything, but now that is a 1, 2, 4 triple, so one of the ones on the right is 4. We've got to use 2 3s. No, we don't. We're using only 1 3. That is very much the point. Okay, we've got 3 and 4 here, and 7 and 8. These other digits on the diagonal are 5 and 6. Therefore, this is 2, 3, or 4. This one is 1, 2, or 4. And there's only one place for 3 on this diagonal. Extraordinarily, it's here. Now, that's not a 3. The 3 that appears on this line is in one of those 2 cells. That's a 2, 4 pair. This is a 5, 6 pair. We've had the high digits up here, and 1, 2, 4. That digit is a 3 at the top. And that means this digit in the circle is a 2. This in the other circle is a 5. Oh, is that not going to work down onto this circle? I thought it was. I can't believe it. That's not a 5. Right, in this column we need another one of 5 or 6. Now they've appeared on the diagonal on the ends. So that's 1, 2, or 4. Oh yeah, look, that 3 is looking straight at that cell. That's how we were going to do that. I just didn't see it. This is also not 3. It's 1, 2, or 4. And look, we've got a triple in the row. That digit is 6. That's going to look down here at least. Wow, I mean, this is incredible. This is just a feat again. Can we really still disambiguate all of this? There's a 3 in one of those cells. I don't know what good that is. None at all, I would imagine. These are the funkies. 2 comes out of those. Oh, in this row, one of those is a 1. So this digit isn't 1. Oh, we knew that before. It's 2, 4, 5, or 6. No, I don't know which. I don't know which. I'm studying it, but I don't know. 5 has gone in this box, and 2. So that also can't be 3. Look, we've got a 4, 5, 6 triple in the row, so that digit is 1. I can only do this by Sudoku. There's literally no other method I have. One of those is a 3. One of these two is a 5. Don't know which one. 1 is looking at that cell by Sudoku. So now 1 is in one of those cells on the diagonal. Is that any good? No. One of these is 5 or 6, but not both of them. So that must be 5 or 6. I could have done that by looking in this box. Oh, so that's not 6. Oh, that's not 6. That's 4. This is 3 at the bottom. These aren't 6. That's a 4, 5 pair. That's 2, 4, not 4, not 4, not 4. 1 here, 4 here. 2 on the diagonal, 1 on the remaining low digit on the diagonal. That one is not 1. This one is 1. This one is 4. Okay, all the 1, 2, 3, 4s are on the diagonal. That's good. These can't be 4. They're a 3, 6 pair. This is 5. That's 6 in the corner. That's 5 in the opposite corner. 4 beside it, 5 at the top of its column. That's a 2 to finish the box. This is a 2. This is a 6 to finish the box. That's now 4, 1, 2. We must know this digit is 6. These are a 3, 5 pair in an order to be determined. Wow, I mean, it's unfolding so symmetrically. It's just gorgeous. That's a 1, 3, 2. We've got a 5 or, no, we've got, this is a 5. So this is a 6, 4 pair. We know the order thanks to the 4. That's going to give me 5 here, 6 here. That's going to give me 3 and 6. That's going to give me 3 and 4. I'm just going to end up having to add up these columns now. Now we knew one of these was going to be 3, 5, 8. So that's this side. 3, 5, 8 leading to 9, 7 in the circles. 9, 8 in the other circles, made up of 6, 4, 7. That gives us 9, 7, 9, 8, and 3, 5. And literally, Blobs has done it again. That is fantastic. Oh, why don't I do the last 2 digits and celebrate? That is a brilliant puzzle. Absolute joy from Blobs. I mean, I was a bit slow with whatever that key deduction was. It was about reusing. It was about visualizing these digits in sets of low numbers. And that was really relatively easy, but I was kind of hornswoggled by everything else in the puzzle, bamboozled by all the possibilities, and I did not spot that for a long time. But once I did spot it, I have enjoyed myself to the absolute max. Thank you, Blobs, for your links, and thank you, everybody, for being with us. We'd love to see you again tomorrow. Do come back for more. Bye for now.